Hello everyone, and welcome to another Minecraft video. In this video, I'll be showing you our progress on our binary storage system. As you can see, we've done a lot of testing, and this is on the TechRock Creative test world, and this is what we've been using to all get on the same world and build at the same time. So, as the title suggests, we will be working on I'll be showing you what the storage hall is and this thing called the temporary storage, and even though it's not in the title, I'll show you how a binary decoder works. So first, I guess I'll just start with the binary decoder, which here is one of them. So this is a very slightly modified version of Gecko's binary decoder. We made it a little bit more compact and changed some of the wiring up. His channel, of course, will be in the description because this is a really brilliant design. So this is where you input the binary, and this has 1023 combinations. The reason why it's not 1024 is because this decoder cannot decode 0, but that is okay because there is a fix for it that we did on the other one, so we can just, looks like the CMP's lagging a bit. Let's see. Uh-oh. Of course it happens when I'm doing a video. So it looks like the CMP is back to normal. So if you flick this lever, this inputs the binary code of 1. And if we encode this in, as you can see, we will get output of 1. If we want to, we can simply input that code. And 1 plus 2 is 3. And so on. And we can extend this really far if we want to. And if we put in 0, it will just reset everything. So that is basically how we activate certain slices in the storage system. So now I'll be showing you our binary storage halls. So we have a lot of versions, and right here is my version 1 design. This is based off of Pala's Java edition storage hall. And how this works is there are 4 water streams on each side, so 8 chests in total, and these do not have filters. So currently this hopper is locked, so it won't pick up any items that flow above it. However, if we get an output from down here, see how this unlocks? So that means the item will flow down into here. So that's how we sort and choose which chest each item goes into without using any filters. And for here, because we cannot lock these hoppers without in an easy way, what we do is we just retract the ice so the item just falls straight down and down into this hopper. Now there are a lot of flaws with the version 1 of this. So many in fact that I just don't even want to mention them. Then here is the version 3. Now you might be wondering where our version 2 is. Version 2 is, I think, is it this one? So this is our version 2 storage hall, but this one is a flat chest hall, and these are not good because you have to use item frames, and those can add a lot of client lag, and it's harder to find your item. And also there are a lot more hoppers that are unlocked, but it was a lot simpler. Then so one of the problems with this was that there was this really annoying water bug. So I'll go demonstrate this over here. And what we did was we retracted the ice, and that caused the item to fall down. However, hello tigers. But the only problem was that where there was a water stream, source block above, so this block right here, there was a glitch where it would create a ghost source block, and it was really annoying. So normally the item will just get redstone, and the item will just flow straight across. But if we retract it, what is supposed to happen is the item falls down, but if you look, it just flows right above. And at first I was really confused. Like, this should be working. And no matter how slow the item goes, it just flows right above. So then what I decided to see if what I noticed was happening was that there was a source block. It was acting like there was a source block. So when you throw items here, they would just float, and they were supposed to sink. And the weird thing is, if I place a block here and break it with my hand, it falls down. And if I just do this with the piston, the bug happens again. And so I decided to remove the water, and as you can see here, there's a source block here, and it shouldn't not be here at all. And it's a very weird thing because you can also pick it up with a bucket. So it does create an actual source block. The first way, hello tigers. The first way I fixed this was that I just used a dispenser to pick up the water, so that there was no more water there to create the bug. But Orpheus Flolan later came in and helped a bit, and found out that if you put a source one block above the hole, it does not create the ghost source. So that's what the main difference between these versions are, and a lot of compacting and lag reducing. And another thing is that we have these comparator readings out of the chest. So what we can do is we can get full signal strength here, then subtract, and we can get the exact comparator output of any of the chests that we want. And we can just disable these when these slices are not active. So there are a lot of versions, and we are up to version 7 currently. So I will fly over here where we have the version 7 storage hall stored. So this is the version 7. So there are a lot of lag reducing factors here, and this server is very, very slow. But even this giant storage hall right here is not lagging it out that much, and the reason is because we only have these two hoppers and this one that are looking for items constantly. And the laggiest hopper action is as I said in my binary storage video, a hopper looking for items from a full double chest and trying to put it into a full double chest. That's because it has to do a lot of different things, and you don't want that. So because we have a comparator output here, we will never be worried about these chests getting full, because as soon as this starts getting full, it will start sending it to bulk storage. And so these hoppers are pretty much locked unless the slice is active. Same with down here. And this one is also for our item elevator. So this will send items up silently. Let's see if I can get these items out. Except for the very end. But so now these are always locked when they're not being used. And this has a composter above so that it's only checking for bone meal in the composter instead of checking for items just floating around anywhere above it, and that reduces lag a lot. So when nothing's happening to the storage system, it rarely adds lag to your world because it's not really doing anything. And this is where we can subtract the comparator signals. So we have these three and one more right here. And then we have waterlogged stairs here. So the source block is one block higher. Same with here. And this here is the maximum length of a storage hall. So this would fit either in a ticking area or a larger simulation distance. Because this is I think 92 blocks long, and this can store all unstackable items in the game, including the Nether update. And this is the binary decoder that decides which slice we want to activate. Now this has pretty much no brain right now, so it's pretty much useless. But the brain will decide which of these 8 water streams the item will go into, and they will all fall down into the corresponding chest. Now, we have done some work on some of the more logical parts of the system. So over here I have my version 1 temporary storage. I'll explain what a temporary storage is in our main chest hall. So the current one that we are using, that oops, looks like the server's struggling to load. Well, while this area is loading, I'll explain what the temporary storage is. So the temporary storage is actually a lot more complicated than it first seems. So what it has to do is, because the system will get full and empty shulker boxes, if it wants to store things in bulk or in one of these slices, it can't do it unless it's a full shulker box, because you don't want half-filled shulker boxes in your system. So what this does is, it first, when it gets a half-full box, checks if there is enough space in the hull, and if there is, it will just empty and put in the hull. That's the job of the brain. And then what the temp storage does is, if it's a half-filled box that needs to be sent somewhere else, then what it will do is it will check to see if it already has an half-filled shulker box of the same item type. If it does, it will send both of them to this thing called the shulker merger. And what this does is it merges 2 half-filled shulker boxes and puts it into one. So you will either get one completely full box and one half-filled box, or you'll get one that is empty and another that is the combined total of the two. And if there isn't an item of that same type with a half-filled box already, it will just store it. And what makes this really complicated is it needs to be tileable with the storage hall. So over here you can see this is right here is my newest version of the temporary storage. And so I'll explain how this works, but it looks like some things are not loading in completely. Some things like chests are supposed to be right here. I'll come back once everything has loaded. So now that the server has decided to cooperate, of course it happens always when I'm recording a video, but this is our current main storage hall. So this uses the V7 storage hall, which is basically my V2 gone through a bunch of compacting and lag reduction by me, and then at the end the V6 and the 7 are basically modifications of mine by Tertar, and then I just went through with V7 and reduced some of the lag with, for example, these redstone blocks. So what this hull has that is different than the other ones is, first, it has a slightly different binary decoder. One thing is that this one can do binary code of 0, which is the first slice right here. It's a bit hard to navigate now. So this is 0 and this is 1. Before, the first slice was just 1, but now we start with 0. That is so it works better with the item to binary. Then we have these 3 bits here. What these 3 bits do is basically a 3-bit has a total of 8 combinations, and we just happen to have 8 different chests per slice. So what these determine is what chest out of the 8 the item goes into. And not only that, but it also goes with the multiplexer. So this is by Tertar, and so we have our comparator readings here. Then it goes through some of this logic here. So what this does is, so this is the output of the decoder for the 8 outputs, but you may count that there are only 7, and the reason is the 8th option is just none of these are on. So currently this is on 0, and then 1, 2, 3, 4, 5, 6, 7, 8. So it gives us a total of 8 different combinations, and then that signal gets decoded through a couple of red coders on each side, and these activate and deactivate certain comparators, and then this comparator signal is either one of these 4 comparator signals, and they are all merged eventually down into this one line, which goes under the hull, comes all the way over here, then which is further merged with one of these 4, and then the output of that one single chest out of all of these, just by inputting a certain binary code, comes out right here. And this will go to the brain. It's just not wired up because we don't have a brain yet. And what this circuit will also eventually do is it will split these water streams apart so that the item goes to the right water stream. Then the rest of this is the temp storage. So as I said before, the temp storage needs to be one-way tileable. At least the actual storage part. The actual circuitry and logic does not need to. And I only extended this to here because I didn't feel the need to do it for the entire hall yet, because I need to move this anyways because it's kind of in the way of these water streams. But here are the temporary storage chests that store the 8 temporary items for each of the chests. So these can be any items. I just decided to name as rename barrier blocks, so it's easy to tell that they are just placeholder items. So what will happen is this is chest 0, 1, 2, 3, 4, 5, 6, 7 in this first slice down here. So I think Tertar wired it so that this is 1, 2, 3, 4, 5, 6, 7, 8. Or actually that starts at 0. But so this can hold 8 different items in these chests. And what it will do is, depending on the binary code, it will shoot out one of these items, and it will cycle through them. Then it will check to see if it's either a shulker box or a the placeholder item. So currently these are all placeholder items because we didn't input any shulker boxes, but eventually these will start getting either filled or unfilled with the shulker boxes of each of these item types. So I can demonstrate how this works. So let me just grab a couple of shulker boxes. And over here we have our 3 binary inputs. So let's just say we go for, so this is actually just 1, 2, and 4. So let's just say we go for item number 4. So the 4th chest. And let's just say we have a half-filled box. So this is the 4th slot activated right now. And this signal is calculated into this red coder and down into the brain of the temporary storage. And so this, in this scenario, basically this is when the brain is like, oh, this box is not full, so I can't put it in the storage. So then what it does is it sends it to the temp storage, and what the temp storage does is first it sees if the 8th item, the 4th item, which is this one, it sees if it already has a shulker box of that item, which in this case it doesn't. But so what it'll do is if there isn't that item, it'll just store it. So this is the input for the temp storage. So this can be led by a water stream, but let's just send this item in here. So that's just the half-filled shulker boxes, and then some timing circuitry will be done, and some of the items will be cycled. Then some comparator will read the signal strength to determine if it's a shulker box or not. Then the shulker box that we just inputted is now stored right here because there wasn't a shulker box of that type anymore. And what happened to the temporary item is it gets sent down into these binary filters. So only this one's unlocked, so this is the only one that can fit into. And if we just break this for a second, we can see that this is where these temporary items are stored. So this is probably 0, 1, 2, 3, 4, all the way to 7. And this can also be called, so when we send a signal down here, it will dispense it down through these hoppers, down this water stream, and it will go down into this chest. So now let's do the second scenario where there already is a box of this type. So this is when you have 2 half-filled boxes, say that are each exactly half-filled. And since we already have a box of that type, what it'll do is first it will just take these items out. Then after a certain delay, it will take only that last item. Then these all get sent up here. So now we have that one is the box that was already in there, and this is the box that we just put in, and these 2 boxes will be merged. So if they have, for example, a stack and the other one has only a stack of space left, they'll be perfectly merged into one full shulker box. I will maybe do a video on a shulker merger later if I can design one, because we currently don't really have a viable design for a shulker merger, but that's not really the important thing right now. So this actually took not too long to design, because I actually did this mostly on paper, just getting the concept. But let's say we put in a different binary code. Let's just say we go for the biggest binary code of 7, and we set the code to 7. Then now that is being outputted, and what we should see is that we take it out of this chest when we input our shulker box. there goes the item. And the binary code for these items are pretty much out of order because they don't follow 1, 2, 3, 4, 5, 6, 7. The reason is because of how Territar made the multiplexer. It's not a problem at all. It's just because it goes up like this. So even though we inputted the biggest answer code, it pulled it out of this one. And this one's 0, so then this one's 7, 6, 5, 4, 3, 2, 1, I think. So we can take it out of here if we just input another shulker box. We can actually watch the items get cycled through. So here comes the one item before it. Then here comes the placeholder item that gets called back. And this fills in the spot again. Now, let's say that we input 1, which is the farthest item. We set the code in. And let's input this thing down here. And we can see the items get sucked out. And then the last item will fall down. And these all fall back down in here in the same order, except for the last one, which is the shulker box from the input, and then it falls down in here. And then the same thing happens when we want another shulker box. So let's get another one. There was some here already, but doesn't matter. And the items will fall in order. And if we had some items, say we were trying to take out this one, these will be stuck here, and then the item will just fall into the first open slot, which is this one. And there it goes. And you may notice that we pull these chests out, and the reason is so we can unlock this hopper, but without pulling items from this chest for just the last item, or else we'll have an item stuck in this hopper, and that is something we definitely do not need or want. And there is one edge case, which is a special scenario, and that is binary code 0. So what will happen is there's no signal here. Then what will happen is because this block gets retracted, this piston is no longer powered, which powers this piston, and which allows the signal to come down into this. So what this is an RS NOR latch. And the reason why this exists is because when the items flow over here, we use this pressure plate to detect the items, and that opens it up after all the items have passed, and then that one delayed item will fall into here. Now the reason why I have to use a pressure plate is, for example, let's say this slice all the way down here was activated. That means that I would have to give it a very, very long pulse extender to wait for the item to pass into here. And that means for each slice I need to code in a different timing. But if I do it with pressure plates, I will have the same timing every single time. The only problem with that is when I'm doing 0, what will happen is it will, looks like the server is lagging again, but it will take one item, so the slot number 1, and it will just put it in this hopper. Then after a delay, it will dispense it. But because it will just flow straight down here, and it won't activate that piston until after it's gone up the elevator, it will just cycle back, and that's not what we want. So what this RS NOR latch does is once this powers, this piston moves down here and causes this to retract like manually. So this will be constantly open, and as soon as this the only item passes down into here, it will then push this redstone block back and close the door. So we can kind of see this in action. So we have it set to binary code of 0. Put the shulker box in here. You see the thing just opens for it, and then the block gets pushed back. Then we can see that this slot is open. So when the item just comes from over there, it falls straight in and finds the nearest open slot. So it would never get out of order. And then if we want to get it back, we can put 2 shulker boxes in. And then the item will travel down to here. Then we can see it call for the item. And then the item comes all the way down here. It gets aligned using this stair trick. So it bounces off these stairs and gets aligned perfectly so that so you might see like cakes everywhere, and the reason why you use cakes and, for example, like anvils and stuff here is because of item alignment. So what we want is that we want the ice effect and for the item to pick up the hopper by the hopper. And what we can do is if we can align it using, for example, things like chests, anvils are directional, so they're not really recommended. Cakes, you can align them perfectly between the 2 blocks so that they'll still get the ice effect and they will be picked up by the hoppers. And that is why you will see things like cakes everywhere. And composters can give accurate comparator data so that we can do some comparator math easily. And before this video ends, I would like to show you my version 1 of the temporary storage, because it has improved a lot. This may seem big and complicated, but compared to the first version, it is a lot simpler. So now I'm back at the original testing area, and this gigantic thing you see here is the old temporary storage, and it is gigantic, slow, and not that good at all. And I decided to use a different concept for this one, and I later realized I could do something better. But here is the one slice, and let me just put in, for example, see, I think I have some more of the items stored somewhere. They should be in here. Actually, I'm just gonna grab a ton more shulker boxes, and let's just say that the temp storage is filled with shulker boxes. So there are a lot of problems with this one, but based on a similar concept, what this one did is it just dispensed all 8 of these boxes. Then after that, they fell through this hopper line, and each one went into one of these hoppers. So there are 8 hoppers here, and once one item went to here, it will lock the hopper so that no more items can come in. So let's just say this is on binary 0, and to start it, I think the input was this here. So we can put this in here. Then the items will start coming down into here, and it's a lot slower. You can see that these are slowly getting locked up, filling with the items, and it is loud, like very loud. Sorry, headphone users. Then that one item will come down into here. Oh, it looks like there's a remaining item from loading from structure blocks messed a lot of it up. But then that one item gets sent down here. So this is to the merger. And then these items will slowly get cycled back. It is just insanely slow. Then they will fall into this chest in the right order. Let's just put item number 8 back into here. Then if we put in a item now, it will do the same thing as the other one, and it will just store it. So these are all getting sucked out. And then after this, it will blow your eardrums out any moment now. Wiring's a lot more messier. So now it will, I think, call for the item over here. So the item should flow down through here. So here come the items any moment now. So we have the one item, and then they should slowly come in. Yeah, it's been messed up after I loaded it in with a structure block, but that's not really the point. I'm just showing you how the other concept worked, and this is all of our testing that we've done. So here is a non-self-organizing bulk storage, and this is a early prototype of my binary bulk storage. It's a bit smaller, and one thing I'll say is I have a new version of this here that works a lot better. Anyways, that's it for this video. Thank you guys for watching. I'll be putting the channels of the people that have helped up in this project so far in the description. And thank you guys for watching. See you guys in the next redstone video.